Why do men have such a boner for superchargers? Because a supercharger makes a man sweat 10W30. Because a supercharger makes more foot pounds than ass hairs in a man's crack. Because superchargers turn your horsepower impaired adversaries into a cyber demon's shit stained toilet paper after a particularly hard wipe. Woof, I agree. Once upon a time, a man named Chris Camaro had a vision. A vision to supercharge his Camaro to 650 on stock parts safely. That vision would take 3 years to realize. In the interim, mistakes were made. Patience was tested. The dream faded. But today that dream is alive. Let me take you with me so we may celebrate the realization of a vision. A man's vision of automotive power.
This is just a preliminary design draft, but it will help streamline the installation and make the final product more robust. Let's start by looking under the hood. Even though the Camaro has a spacious engine bay, there are several restrictions that complicate the intake routing, especially for the dual mode intake planned. The electric supercharger needs its own inlet filter, as you might expect, but because it won't be running all the time, it acts as a restriction when unpowered. Therefore, there's a second path for air to feed the engine when running naturally aspirated. However, this would be a boost leak when the supercharger is on. To remedy this problem, we have a T-union pipe with flapper that only opens when there's vacuum coming from the engine. This makes switching from NA to boost automatic. When under boost, the supercharger draws fresh air through the filter and forces it into a 3-inch section that has to be adapted to 6-inch because the valve body inlet diameter is only available in that size. From here, the flow travels under the car to the passenger side and up to avoid interference issues. To preserve the intake air temperature sensor, the flow goes through a MAF sensor adapter and then through a blow-off valve before finally entering the LS3's throttle body. It's worth noting that the nitrous spray nozzle is also plumbed into this final section of pipe where it can avoid sensors and cool the intake charge as much as possible. Since the supercharger runs off a brushless DC motor, it needs a controller module which will be located here. The 300 or so amps needed to feed the supercharger motor will connect through cables to the rear of the vehicle, where 2 lithium polymer batteries will be stored and monitored electronically. Finally, the entire system will be computer controlled from a touch panel located inside the cabin. Well, ladies and gentlemen, here it is at last, the electric supercharger that I'll be installing in my Camaro. Not quite what you were expecting, right? Now that I've got a good opportunity to take a look at this thing, let me explain a little bit more about it. As you can see, it's basically a conventional turbo housing coupled directly to an electric motor. This is similar to a T76 Garrett turbo housing, and it's using a companion flange to mount directly to this brushless DC 10 kilowatt motor. It's essentially a 3-phase AC motor. It's called a brushless DC, but it works on a similar principle to a 3-phase AC. It's got the 3 phases A, B, and C here. Very heavy gauge, as you can tell. 10 kilowatts. So this thing can handle quite a bit of power. The setup that I have electrically, it's not going to be operating at full capacity. And that's just limitations of how I've got my electrical system hooked up. But it could, produce a lot more boost than what I'm going to be setting it up for. But I'll be getting probably around 5 to 6 pounds of boost out of this thing, depending on the RPM that I run it at. But essentially, you can see that it's not that big. It's fairly compact. Brushless DC motors tend to be very efficient. Even though they draw lots of power and they produce lots of torque, they're pretty compact. So this whole thing should fit nicely into my engine bay. And basically I've got this thing here today because I want to do a real quick bench test on it. I just received it in the mail recently. This is from Thomas Knight Superchargers. I'll put a link in the description. But essentially this is a a guy who does custom electric boost applications, and he does all sorts of different types. You know, some of them have weird transmissions attached to them and stuff like that too. I actually, this is the second one that I've gotten. Actually, first one was too big and it didn't fit in the car, so I unfortunately had to exchange it for this. But that one was a DC motor, much bigger. But in any case, yeah, he makes these things, and I'm going to be testing this because I just got it in the mail recently, and I want to make sure that it works with all the supporting hardware, because these brushless DC, they don't work the same way as a normal DC would. Normal DC, you hook it up to a battery and it goes. These things here, they need a special signal generator to switch the power between the 3 different phases, and that's how you control the speed and everything like that. So that's what I've got hooked up here, and I'll show you. By the way, this is probably the most hackish electrical work I've ever done in my life, so for God's sakes, please don't do this. I only did it because to do it properly would require a lot of investment of time and energy that I didn't think was warranted just for a simple, quick, dirty test that I'm going to be doing right now. It's like a 30-second, just turn it on, check it, see if it works, turn it off kind of thing. But yeah, don't do this. You could have fires and arcing and all sorts of horrible things happen. So you got the 3 phases of your motor going to these 3 wires here. These 3 wires go into this weatherproof plastic box via these terminals over here. And inside the box, you've got a company called Castle Creations. They make these RC, for the hobbyist community, they make these RC controller units. And this is what switches the high power from the battery to the 3 phases that goes to the motor. So you've got your 3 phases coming out here, and you've got your battery power coming in there. And this is your, it contains all your power MOSFETs and stuff like that. So what you do is you feed this with something like this, which is a signal generator. It's also meant for RC applications. And all this is a low voltage square wave generator, and it produces a very standardized type of signal that all the RC products recognize, and this thing recognizes it, so they're compatible. And you just turn the knob and it'll change the width of the square wave to tell the controller how much speed you want, and then it'll change the the signal going out here, the high power waveform coming out here, and that'll go to your motor and change your motor torque and speed. And then of course on the other end here, you got a couple more terminals, and this goes to your battery. And again, using electrical tape, I got a couple of these are the proper connectors. This is exactly what you should be using to connect to a lithium polymer battery, designed for like drones and helicopters, whatever, these high power lithium batteries. This is what you would use, these bullet connectors, but you definitely would not tape them on like this. So again, really hackish, but should be okay for the few seconds that I'm going to be running it. So yeah, that's pretty much the setup. And when it's in the car, all of this stuff here is going to be mounted under the hood area, and then of course the battery will be somewhere else. I'll probably put that in the trunk and have these wires run back to there. But and I won't have this either. This will be replaced by my own controller, but it'll do the same job. So without a whole lot more talking and delay, let's get to the fun part. So I'm gonna grab my battery. It's just about finished charging. I want to get as much voltage as I can so that I can get a good range of speeds to show you. But I'm gonna hook that up, and then we'll fire this baby up and see what you can do. So here's the big beefy bastard that we're going to be using for this test. It's a lithium polymer battery, 5,000 milliamp hour, and it's got a 60 C rating continuous and 120 C rating for pulsed applications, so should be able to do 300 amps all on its own. But I'm going to be using 2 of these when it comes time to install it into the car, but for now I'm just going to be using this one because I'm not going to be loading it too much. But yeah, I'm just going to connect this to the terminals, and this thing's got 6 cells in it, so it's got a nominal voltage of 22 and
22.2, and fully charged is something like 25.2, which is what it's at now. So the controller, the Mamba controller from Castle Creations, is capable of handling up to 30 volts, which is why I say that there's some limitations here. There's additional headroom that I could realize if I was getting a different battery with a different voltage to it. I might work something out later for that, but for now let's just assume that this is what we got. So it's pretty much 25 volts running the motor, and so we're going to see what that's capable of at that voltage and at that current level. It should be drawing pretty close to 300 amps when it's fully loaded, but because it's just venting to atmosphere right now and there's no actual resistance on it, it's probably not going to be at full load, but we'll get a good idea of what type of power levels we can expect just from this quick test. So let's hook it up and see what we can get from that. Oh, and I forgot to mention too, there's a calibration involved with any kind of brushless DC, especially when you're using it for an RC application. You know, where all the hardware that runs it is like RC hardware. There's like a standard that all the equipment is designed to, where it has to calibrate itself when you first connect it. So as soon as I connect this, it's going to go through this initialization sequence where there's going to be a bunch of tones and stuff, and I got to sort of set the range of the throttle and all this. So just letting you know what that's about, and then once that's set, then the throttle should be primed and ready to go, and as soon as I turn the knob, it should start up the turbo and throttle it from there. I'm also just hooking up a multimeter just so that I can monitor the voltage too. I figure why not? Good information to have. So let's get started and hope I don't blow anything up. Hang on a second, that's not what I expected. Okay, I couldn't tell you why, but for some reason it didn't go through the initialization like I thought it would. Instead, it just seems to be using like a default setting. I'll have to like screw around with it and figure out why it's doing that, but for now it seems to be already kind of set up, because as soon as I turned the dial it started blowing. So yeah, let's show you what that looks like. That's low throttle, that's just barely touching it. Holy shit.
Holy shit.
Okay, so yeah, it's working correctly, and pretty impressive. I didn't expect that kind of performance from it, to be honest. I was kind of expecting something a little lukewarm, but yeah, this'll do. Let me see if I can crank that up again. I got to be careful though, because I don't want to blow the whole thing up, like because basically the Mamba, the controller for this thing, is only capable of passing like so much current, and I don't even know what the current is, because it's not like there's actually no documentation that I could find for this thing. See if I can get a better angle maybe of the impeller. Wow. Yeah, I'm very satisfied with that. I think that this is going to make a really good supercharger for the Camaro. If it provides the amount of boost that I think it should be able to push the car from the stock 426 horse up to somewhere around 550, which is around where the ZL1 is for that model year. And then I can get it higher than that with boost alone, but I think I'm gonna mix my methods and have like nitrous as an intercooler, and I'll probably throw like 100 shot of nitrous on it too, and then that way I'll be able to get it up in the neighborhood of around 650, with the two combined, and that should be pretty sweet. So yeah, successful test, and I would say that everything's looking nice and healthy. Everything's good. I didn't see any problems. So looking forward to throwing this under the hood and seeing what she's capable of. So until next time, I'll see you when I've got more work accomplished that I can show you.